Okay, you guys thought you might get out of some boring math because you got a sub. Instead, I'm just going to bring it to you from the comfort of my own home. So, today what I want you to do is understand a couple things. So, what we're going to see on Canvas for week 3 is you're going to see my PowerPoint. I'm going to go over this with you just right now. Then at the end of the PowerPoint, I'm going to ask you to do pages 20 and 21 in your workbook. And this is where you're going to see that. It says, following along with the PowerPoint, at the end, you are asked to practice. Do your best. This is a completion project and a pretest. So I'm just trying to see how much you know after the little introduction that I give you today. And that means if you're successful, we skip ahead, we're done. If not, you don't quite get it, we practice some more. So once you've completed pages 20 and 21, you will just take a picture of that with your phone or your iPad or your computer and submit it. Or you can just type it right in if it's easier. There's 10 questions. You can just type it in on your computer, or you can show me your workbook when I come back to school. So any of those will work just fine. So that's what we're going to do today, the PowerPoint and this workbook. Now your assignment, and this is worth points, and it is worth points if it is correct or incorrect, so you want it to be correct. You will click on this. This isn't due till Friday, so you know what today's expectation is. It's to have this assignment done. So we'll do the workbook in class with the sub. You'll have 20 and 21 done. And it shouldn't take you more than about a half hour. And then this is your assignment. And this assignment you will do as probably as homework. But when you click on this, you can open it up. Now you can either print it and write right on there. You can write it on a blank piece of paper, or you can just type it in on the computer the same way as the other one. Now here's the thing with this, because it is worth points and you might have questions, I also put the answer key on here. That's so easy. Don't cheat. Try and do it. And when you get stuck, go refer to the answer key. All right. Okay, so here's what you're going to see when you get to the PowerPoint. It says, I'm sure that I miss you more than you miss me, because you're probably already bored. Okay, open up your Walsh books to page 16. So you're just going to follow along. I'm going to go over what you're going to see on page 16. Okay, so it looks a little crazy on this, but when I make it full screen, it kind of looks really weird. So basically what it says is that Javier has 750 in his bank account, and he earns 3% interest on this. So how much money will he have left after 5 years? That's the question. So we're going to first find out how much interest he made, and then how much money, if we add the interest to that 750, that will give us the total amount. Now, one of the key things to this problem is remembering that we can't use percent in math without changing it to a number. It's not a number, it's a percent. And percent means per 100. So you can just divide percents by 100 and get rid of the percent, or you can move the decimal block 2 places. And so that will make it 0.03%. So this is what you're going to write on number 1. It says, how much interest did Javier earn in 5 years? So you're going to write this right here. 5 parenthesis 0.03 times 750 parenthesis. Okay, and that equals $112. And please make sure that we give our answers as dollars if it's asking us for an amount. Now, remember, when we're doing problems like this, we need to include the parentheses. So we have to multiply what's inside the parentheses first, and then we multiply the 5. So order of operations becomes critical for everything that we do. Don't I kind of look like an X-Man when that line's right there over my eyes? That's kind of cool, huh? Okay, So when we put this all in on a calculator, and please feel free to use a calculator, you'll get $112. Well, the next question says, then what's the total amount that Javier is going to earn? And this is what you're going to write. The total amount is going to be that 112 that we just found, and we're going to add that to the 750 that he had, and we're going to end with 862.50. And again, you can put that on a calculator if you need to. Okay, so here's how we do it. This isn't the part, you don't need to write down all these words. You need to write down this. But how do we do it? We find the total amount by adding the interest to the deposit that he had. And then that tells us what it will be after 5 years. Okay? Yay! You made it through 5 minutes of boring math video, number 1. Number 2, we're already on page 17. Okay, so on page 17, I have a little story time, but it's not that fun because it's a math story, but still better than writing stuff down. So just listen for a second. Okay, we've talked about expressions. We've talked about them a lot lately. Okay, and one of the things that we talked about is expressions in math, algebraic expressions. They're going to contain terms, right? They're going to contain add and subtracts and things with variables, and they don't have equal signs, right? Equal signs occur in equations, but we can still solve for expressions. So I wanted to make that clear, okay? Expressions, just because they don't have an equal sign doesn't mean we can't solve for them. Sometimes it means we're substituting in, sometimes it means we're simplifying. And so I wanted to remind you of that. One more for story time. This is what we're doing, okay? We're telling or reading a story, and it's described just verbally. And then we're going to translate that into an algebraic expression. So we're going to translate that into numbers, variables, and things that we could simplify. One other thing that we've talked a lot about is a constant. Remember, a constant never changes. North Star, breathing air, boys having cooties. Constants never change, okay? So constants are just something that remains the same, and those are our numbers. 5, it never changes, it's just 5. Negative 27, it's just negative 27, okay? Those are constants. All right, last bit of story time. We have to follow order of operations. Now, for a quick review of order of operations, it's kind of, we sometimes say, please excuse my dear Aunt Sally. Did any of you guys remember that? I should be seeing some head nods. Or maybe you're thinking of something else that a teacher taught you a while ago to remember that it's parentheses first, then exponents. And your assignment today will try and trick you with that. It's going to try and trick you by saying, can you multiply first and then do an exponent? Can you skip the exponent and do parentheses? Okay, so please excuse my dear Aunt Sally. That's how I was taught it a long time ago. Parentheses, exponents. Parentheses first. Parentheses always come first in math. It's the very first thing you do. Okay, after parentheses, then we do exponents. Okay, so remember, an exponent is this little number or variable that's tiny and up in the corner, and that's what represents the exponent for a base. The big number on the bottom is a base, and the base will be multiplied the number of times that the exponent indicates. And for example, if it was a 2, if this little b was a 2, then we would have 2 a's, right? Okay, so on to page 17. One of the common mistakes I want you guys to remember is that sometimes our expressions get translated incorrectly, and it's a common mistake. It's easy to make, especially if you see something incorrect. A lot of times it looks correct if you see it written. So I found one of the secrets is to go back and just do the assignment all on your own. Okay, Here's what it says on page 17. A new car loses, on average, a value of $1,800 per year. So Naya buys this car and it's $25,000. So we're going to let this expression right here, and it gives us this in the book, represent the current value of the car. And it says we're going to refer to that. So what effect, if any, does the changing the number of years since Naya bought the car have on the original price? If she's had the car for 10 years, did it change? Does that mean she paid $1,000 for the car? Think about it. How much did she pay when she bought the car? So did she have any, that was a constant, right? That's a constant value. So when you see something and you recognize that it doesn't change, it can't change, that's how much it is, then that always goes in just as a number, okay? That's a constant. Now, this is a key word I love, per year, because that usually means that means I'm going to have to add something. That means it changes. Okay, so if it changes, it means that I need to add a variable. And this time we added a y. So let's quickly talk about what we put in our book. Number 1, the term 1800y, that represents the value the car loses each year. And how do we represent loss? How do we represent loss? We're subtracting. By subtracting, that means we're taking away from it. Okay? 2,500, represents the price of the new car, and that was a constant. That was something we talked about. It couldn't change. Because this does change per year, or each time I add a year, I need to subtract more. I add the variable. Okay, so that's what we do. Now, number 2, it says for in our book, determine the effect that the number of years has on the original price of the car. So as y increases, the original price of the car is not affected. It doesn't matter. It still was $25,000 when she bought it, right? That was the original price. So the term 25,000 is a constant term. Did you like that? Constant term. Okay, so flip your pages over really quick. Last one. Oh, you're doing so good. We're almost done. Okay, this is on page 18. And it says to calculate the perimeter. So remember, the perimeter is walking the edges of an isosceles triangle. So a triangle with 2 equal sides. The expression is this: 2s plus b. That's what's used. Now, s represents the sides that are congruent. There was 2 of them, so we just multiply by 2, whatever that length is. And b represents the length of the base. Okay? So what effect, if any, does increasing the length of the congruent sides have on the expression? Okay, so remember the expression was this: 2s plus b. So if I change the length of the sides, it'll change the value if I'm solving for it. But it doesn't change b, because b is independent. The base itself was independent of that, meaning I can change this, but this doesn't necessarily change because of it. The total will change, but not this. So what do I want you to write in the book? I want you to write this: b is independent of s. Okay? All right. Now, determine what effect, if any, increasing the length has. So the length of the congruent sides s is increased. The product will also increase. If s is decreased, the product will decrease. But either case, the value of b will not change. And that was the important part, right? Because it was 2s plus b. Okay, so the last thing I want you to do, this is what you're going to do today with the sub. You're going to turn to page 20 and 21. I know this is hard, so you can check this video for extra tips. Your assignment today is going to be taking a picture of what you complete. And then, if not, I'll need to check your books when I come back to class. This is a pre-test. Please don't stress about it. It's a matter of completing it and doing your best.